So in the previous video, you saw me calculate the standard deviation for this set of data, and I made a comment that you don't need to memorize the formula, that I just wanted you to know that and how it works, and that your calculator can calculate it for you. That the true reason why we are talking about the standard deviation is so that we can answer probability questions and talk about values that are significant in comparison to the mean. So this might seem very daunting, these two images that I just pulled off of the internet, but what you see here in the center is mu, and then this is the symbol for standard deviation. And so you could take the mean of a population, be it whatever you're measuring, and then if you subtract one standard deviation from the mean, you add one standard deviation to the mean, that range of values, 68.2% of all data will fall within that range of values as long as the data is symmetric, normally distributed. What you see in this other graphic, those similar percentages, our textbook uses this 68%, 95%, 99.7%, and those three percentages relate to 1, 2, 3 standard deviations away from the mean. In this graphic, you see that the center of the data is 5 foot 8 inches, and that's to talk about the height of US women. So there's lots of data that are normally distributed. You don't have to have normally distributed data in order for you to be able to calculate these things, these measures of variance. So of variability, variance. So these are your symbols. Okay, we've got the population standard deviation, you've got the population mean. You need the mean to talk about standard deviation because standard deviation is the distance generally that data is away from the mean. And then you have this other measure of variation, which is variance. And it's no coincidence that it's the same symbol. It's just raised to the second power. That is exactly what variance is. I'm not going to make you calculate variance. Again, your calculator does it for you. And that is the symbol for it. So the empirical rule, again, is how we measure whether or not we have values that are significant. And there's this range rule of thumb that your textbook will continue to reference in the next couple of sections that uses standard deviation and significant values. Standard deviation is the single most important measure of variability, variation. And here are some important properties of it. It is the measure of how much data can deviate or are dispersed away from the mean. And the mean is a measure of center. So how close are your data points to the center, loosely speaking, to the data. The value of the standard deviation is never negative because of the squaring, right? It's only 0 when all the data values are exactly the same. And there isn't a whole lot of data that is that unique where everything comes out exactly the same. Large values of S indicate large amounts of variation. And this video is more specifically about this concept of identifying significant values. So something that is considered significantly low in a data set would be if the value was 2 standard deviations less or 2 standard deviations greater than the mean. This is what this illustration is showing. So the empirical rule shows you that there's 68% of all data points lie in this region. We don't consider that to be very significant. That's I don't want to say it, but that's like average, right? Most people, a lot of people are in there. You could say most if we're talking about people, because that's 68% of the population. And even 2 standard deviations away is not really significant. 95% of all values lie within this range. And so significant would be the upper and the lower part of the data. That is so far away from the mean that they're considered to be significant. So you've got a couple of visuals here of random data, not random in the sense of statistics, but just like random to you. So they measured the volume, then the amount of Coke that was in a can for all these different cans of Coke, and then in comparison to Special Cola. And you'll see that what this histogram is showing is that the amount of Coke found in a can, if you randomly selected how many, you could arguably say maybe they're like 50 total here. You could try to figure it out. There's 17 and then there's 6. So let's just say, generally speaking, they randomly selected about 50 cans of Coke, and you see there's not a lot of variability. Over here with the Special Cola, you don't know if you're going to get 14.4 ounces or 10 ounces. There's a large range. So range is also a measure of variation. But what we are honing in is the standard deviation of this one should be very low because the values are closely clustered around the mean. And then over here, we would expect that the standard deviation is very, very high. So while their means are exactly the same, and you're taking this from me, I'm telling you the means are exactly the same, they vary greatly in terms of their how they're dispersed. So one quick way to estimate the standard deviation S is to find the range and then divide it by 4. So the range is the largest value in the set, 14.5, minus the smallest value in the set. And they say that if you wanted to approximate the standard deviation, not doing the huge formula, that you could just take the range and then divide it by 4. So your textbook will ask you to do that in this section, but then after that we would use the calculator, or you would actually calculate the standard deviation. You'll always use the calculator. Another tip from your textbook is that you want to carry one more decimal place than is present in the original data. So, this data I was presenting here, if it's 13.5, your standard deviation should get rounded to 2 decimal places. So that is the most important of the 3 measures of variation. Again, the 3 measures are range, standard deviation, and variance. And variance is directly related to standard deviation. Literally, variance is just the standard deviation squared. So here's your formula for variance, and this would be the formula for the population variance because we're using the mu and the capital N, and then you also have sample variance as well. So variance is kind of just thrown in there a little bit as something that you can look at that helps you describe variability, how the values are dispersed. And this is quite a lot of information. You do not need to write any of this down. It is a little bit about units. If you're talking centimeters in the original data, then the variance would be centimeters squared. So that's a little bit about units. And that variance can increase dramatically with the inclusion of outliers, so it's not resistant. Talking about that first video. Variance is never negative because standard deviation is never negative, and that sample variance is an unbiased estimator. And we'll be talking more about this concept in chapter 6 and 7. Variance is a statistic. The variance is a statistic used in some methods, but for our present purposes, it has the serious disadvantage of using units that are different than what we are talking about. And so that was kind of like my comment. It just kind of gets thrown in there. So there you go. That completes this lesson. Please try your best on the Pearson MyLab assignment, and I'll see you again in the next video.